Alright, so this is the AP Calc AP practice quiz number 3 that I have here on Schoology. I've never seen these questions ever before, at least I hope I've never seen them before. So there's 10 problems and I have 27 minutes, and this is a calculator section. Usually you're allowed to use your TI, but for the purpose of recording this, I'm going to use Desmos. And personally, I like Desmos a lot easier. If there's something I can't do on the Desmos, then I'll explain, I'll do it on my TI. But I'll just use Desmos as a calculator whenever I can. So here is number 3. Ignore the 0 out of 10. I'm just doing the slate. Um, let's see what else. Okay, derivatives in context, limits, and integrals. Okay, that's pretty much all calculus. But all right, all right. We'll see what we can do here. 3, 2, 1. Oh, okay, if R. Okay, I might have seen this question before. I might have not. I don't know. But uh, if R of t is equal to, here, it's like, yeah, c to the sine of t. What is r to the 14? Okay, what is this right here? Um, what is this right here? This just refers to the 14th derivative. And, um, okay, the 14th derivative. This might seem pretty scary, right? But a cool thing about sine is, okay, we start off with r of t, right? So r of t is sine, right? And r prime is cosine. And then r double prime, right? If you want to take the next derivative, is negative sine. R cubed, not cubed. R third derivative, that's just like this. You just put three primes right next to each other. That's negative cosine. And then r to the fourth is sine back again. So if you notice this, you're going to go to sine, cosine, negative cosine. Oh, I should probably do that. So you're going to go sine, cosine, negative cosine. Then it's going to repeat every 4. So from 4, 5, 6, and 7, it's going to have the same sine, cosine, negative. So it's going to repeat that same pattern. So basically, so 14, right? 14 divided by 4 gives you a remainder. So that's 14 mod 4. So it's a remainder is 2, right? So it's going to be the same as the second derivative. So it's going to be the same as negative sine. So sine pi over 3, that is just uh, if you use unit circle knowledge, pi over 3 somewhere up here, and then that's root 3. So it's going to be negative, and then you have root 3 over 2. So that's going to be A. I keep forgetting to show my screen right here. But there is my work for number 1, and I'll move on to number 2. Um, so number 2. The derivative of the function f is f prime. Okay, that. I'm just going to write that down. X cubed plus x whole squared cosine 2.5x. Alright, so what intervals is the graph f concave down? Okay, so concave down means that second derivative, or in this case f double prime, is negative, right? Or less than 0. So what we need to do is we actually need to take the derivative of this right here. So because we're already given f, so assuming we have f, we're trying to see if f is concave down. So the second derivative, first derivative is right here. Second derivative, we just take the derivative of the first derivative, right? So f double prime is, okay, so here we have chain rule. Let's see how much time I have. Okay, cosine 506. All right. So then first, so these are here, right here. Let's just call this u and v. So it's going to be u prime v plus v, my v set right there. U prime v plus v prime u, right? So u is going to be, what is it? The u prime is just going to be, this is no, chain rule. So yeah, I bring this 2 out here, just treat this as one quantity, and then inside I take the derivative of this is going to be 3x squared plus 1 right there, u prime v. So I'm going to multiply that by cosine 2 pi of x, and then add that on to v prime. So v prime, that's going to be negative sine. Yeah, so it's again chain rule, negative sine 2.5x, and then you have to take the derivative of this inside part, which is 2.5. So v prime times u. So that's this right here. Okay, so I need to see when this is less than 0. So now I'm just going to go to my Desmos right here, and I'm just going to call this f. Oh, actually, just going to call this g. G is going to say 2x cubed plus x times 3x squared plus 1. Make sure you're putting parentheses in the right spots. I'm going to add that, or here it's going to be subtracting sine 2.5x. Oh yeah, I should have the 2.5. 2.5 multiplied by this function right here. So I'm just going to say x cubed plus x squared. There, there we go. 2.5. Yeah. Okay. Should I do this right? That would be really awkward if I didn't. Yeah. Yeah, I don't see why. Okay. 2.9. What are the answer choices? On what intervals of -1 to 1? Okay, I'm probably doing something wrong. 3x. Oh, did I? Oh, I forgot. I forgot the cosine right here. 2.5x. There we go. Yeah, so, okay, these numbers look a lot familiar. Okay, I just forgot one thing. Oh, I do not know what happened there. Let me go back, Control Shift T. Okay, there we go. Uh, okay, so then this has to be less than 0, right? So it's from here, negative 0.466 to 0, and from 4.6 onwards to 1. So, yeah, B. All right, let me pull up the whiteboard. Yeah, and then here's my work over there. Uh, Honestly, I'm going to shrink my, I don't know. Yeah, there we go. I'm going to shrink this a little. All right. We spent, okay, a good chunk of time with that, so let's go a little faster. Um, Number 3. Uh, okay, dt is equal to natural log of t plus 2 over 1.5 cosine t squared. Okay, I hate this. Speed is constant. Okay. Okay, so everything's talking about the speed increasing, speed decreasing. Okay, good to know. Speed constant. Speed is 0 acceleration. I'm just gonna say accel. So let's say the speed is not increasing or decreasing. Speed is acceleration. So they're all talking about acceleration. So I'm going to find the acceleration, right? And let us. Okay, I don't think I could do this on the Desmos. But here what I'm going to do is I'm going to type in math8, say d dx, and then I'm just going to plug in, actually, graphs. I'm going to go put in this entire thing. So ah, natural log button not working. Oh my God. There we go. Natural log of x plus 2 over quantity 1.5 plus cosine x squared or t squared. Um, right, okay, so I got that. I'm going to put that, so I'm going to take the derivative of that, and it's at x equals 1.9. Everything is at 1.9. So I get a negative number. If I get a negative number, um, oh, I should probably just find y, no, y1 alpha trace, y1 x equals 1.9. Okay, so here I get um, the acceleration is not positive. The speed is not constant because I get a number. So here I get the number is negative 5.9. So it's not 0, so it can't be C. Um, eh, sorry, it can't be D. Acceleration is not positive, it's only negative. So it can either be A or B. So here, what we need to do in order to determine increasing or decreasing, if velocity and acceleration are same signs, then it's increasing. Here, the speed, so v of t, it was like 2.23. So they're different signs. If they're different signs, that means it's decreasing. So therefore, it's b. All right, I need to go a lot faster. Um, did we already do this? Yeah, I think we already did this in another one. So I'm just going to choose the answer and move on. G prime. Yeah, this question was a repeat, so I'm just going to move on. The answer for that was 10. I'll explain it later if I have time. Um, 4. Oh, I answered this on accident. Okay, continuous and differentiable function is given, but this. Okay, so if it's continuous, then, okay, so we have ax plus 2, x is less than 3, and we have x squared plus b, and that's x greater than 3. So in order for this to be continuous, this and that, both the top and bottom, have to be the same f of x. They have to be the same output to the same input. So let's say at 3, right? So we have 3a, sorry, yeah, 3a, so x equals 3. 3a plus 2 is equal to 3 squared, right? So that's 9 plus b. This is a b, right? So we have 3a plus 2 equals 9 plus b. And let's put all of this on the same side, right? So we have 3a um, minus b equals 7, right? Okay, and if it's also differentiable too, that means f prime, right? They have to have the same values. It has to have the same slope for the top and bottom. So I'm just going to take the derivative of the top and bottom. So that's going to be a. This derivative of top is just a. The derivative of the bottom is just 2x. So that's also x3 equals 3. X is greater than 3. My bad. So then here they need to be the same. So then just a is x equals 3. It's always going to be a. There's no input for x. And the derivative at no matter what x value is going to be the same. So the slope of f of x will always be the same for the top one. For the bottom one, the slope is going to be 2 times 3, which is equals 6. Then we get this equation a is equal to 6 right here. So we can put that in here. So then 3 times 6 is 18. 18 minus b is equal to 7. B is equal to 11. So then now b minus a is 11 minus 6, which is 5. All right. Okay, fun. Another integral. What is this? 6. All right. So integral of 2e to the x squared dx. All right. So here's what I'm going to do. First, I'm going to bring the 2 out. And okay, so think about derivatives, right? So if we were to just take the derivative of e to the x over 2, right? It would just be e is fancy that way, right? You can just just say the exact same thing. But also remember we have this half x, and this is technically like an inside function. So then we have to multiply 1/2. So what we see is this x over 2, whenever you take the derivative, we're multiplying by 1/2. So because integrals are the opposite of derivatives, if we're going to be multiplying 1/2 every time we take the derivative with x divided by 2, that means we have to divide by 1/2 whenever we're taking the integral. So over here, actually what we need to do is, here I'll show you. This is a u substitution technically, but we put half right here, right? So we have half e to the x squared. And if you take the integral, sorry, the derivative of, okay, I'm messing myself too much. But if we take the integral of this, right? Um, if we were to divide by half, because yeah, if we divide by half, then this goes away, right? But here we multiply half inside the integral. In order to outdo that, we need to multiply by 2 outside the integral, because 2 times 1/2 equals 1, and then we make the same thing, right? So you can see that this one right here is equal to the same thing right over here. And then now over here, I'm just going to bring this down. That's going to be 4. Then integral of this is just going to be e x over 2, and then you have plus c. So that should be your answer right there. A. How are we doing on time? Okay, we're doing a lot better on time. This is funny. Oh, never mind. I just thought I was just reading stuff incorrectly. So we have, after a game, people leave the stadium at a rate of RFT. Alright, accepted values are shown in the table. Use okay, left Riemann sum is going to take a long time, so I'm just going to skip and move on. Okay. Select the equivalent expression. Um, Honestly, I just write these integrals out and do it that way. I see what they're trying to do here. So they're going to say u is equal to x plus 1. And they're going to be like u minus 1 is equal to x. So then, yeah, so then what you're going to be left with is u minus 1 to the 7th times u. Oh, no, that's wrong, that's completely wrong. U minus 1 is equal to x, and then you replace this with u minus 1. So it's going to be u minus 1 times u to the 7th, because u is equal to x plus 1. So then you can just replace x plus 1 with u. And then, what is it? U is equal to x plus 1, right? So then du dx is equal to just 1. And then if you do clever multiplication, you get du is equal to dx. So then, instead of dx, you can just say du right there. So this is what they're trying to get at. And then you can substitute, you can expand this, and you can do a bunch of stuff that way. So that's going to be d right there. Let f be a function such that f of -1, let's see, f of -1 is equal to 14, and f of 8 is equal to 2. Which of the following conditions ensures that f of c is equal to 8? Which of the following? I think this is mean value theorem. I don't know for sure. See, okay, let's just think about it, right? So let's just say we have a number line. So this is -1 and this is 8, right? So if you can break any of one of these and it's false, right? So let's just say f of 1 is equal to 14. I'm just going to say right there. One dot right there. Let's say red dot right there. Another thing is that, let's say this is 2. Another dot right there, right? So if f was decreasing, I'm just going to say decreasing. Well, I could do this, right? And it's not decreasing all the way, right? So here it's increasing. So d can't be right. Let's break another one. I think I can break B easily, because I could have something like this, and these are called kinky points, I guess. What is it? These are kinky points, and what is it? These are technically not differentiable. Like, how can you have a slope over here and a slope over here? How can you have two different slopes at the same time? That's impossible, right? So then B can't be right. And then, which of the following ensures? Okay, this is weird. It's either between A or C. Um, I really want to say C. How much time do we have left? Okay, we have time. F is defined for all values. Yeah, because I don't know, like, you can say that, yeah, it can pass through 8, but, hmm, okay, I'm gonna come back to this one. I don't know, I don't know if this says anything. I don't know if this says anything. I'll come back. Um, the top. Uh, okay, velocity. All right, let's just do that so quickly. Mark, velocity of this car is given v of t, 4.2, square root 3, 2t. She has at the mile mark 12 at t for 6 hours. Okay, so think about, this is how I like to think about it, right? So your position at one point in time, right? So let's say position at 6 is equal, sorry, 6.5. Let's actually do that. Okay, I need to give myself enough time. Okay, so I'm just going to be very, very quick about this. But position of 6.5, your final position is equal to your initial position, which is p of 6, plus the change in velocity times the distance you've traveled between the two positions. So it's going to be v of t, dt. So yeah, that's basically what I'm going to do. Oh my God. So this, you have the starting position, right? So it's to say final is equal to initial plus change, right? So a change in velocity multiplied by time, that's going to give you a change in position. So this integral gives you a change in position. So it's initial plus the change in position equals a final, right? So P of 6 is 12, right? So I'll add 12 later on, but all we need to do is we need to do the integral of 6 to 6.5 of, because that's the initial and the end, right? So of this function right here. So that's going to be 4.2 square root uh, t squared plus 2t, and then say dt, right? So that's going to be 15. So the initial is 12, right? And then the change in velocity at that time, right? It's the change in the position, actually, I should say change in position is 15.079. So then the final should be 27.079. No. Am I doing something wrong? 4 point. Oh, I said t squared. Huh. T cubed. So then, yeah, that changes everything. So I have 33.648, then add 12 to it. That's around 45, 46. Yeah, so that's around 46. Okay, 4.5 minutes left. Okay, let's do the Riemann sum first. Okay, Riemann sum. During the first 15 minutes of the game. Okay, so I'm just gonna graph this. So it's 300, 300, and then say 100, and then say 50, right? So then this is at 3, 5, and 15. So left Riemann sum, I'm just going to plot all these points, 0, 300, 3, 300, 5, 100, and then 15, right? So 3 subintervals. Okay, so left Riemann sum means that we're going to use the left Riemann point as the height, so we're going to use this. So this interval, this is the left, right here, this interval, this is the left, so we're going to use that. In this interval, this is the left, so that's going to be our height. And then in this interval, this is the left, so we're going to use that height. So then this is, okay, R of t is the number of people who leave. So then we just multiply, this is the rate, right? And rate times time, right? This is something like people per minute, right? Rate is people per minute, and then time is minute. So then you cancel those out, you're going to get the number of people. So if 300 people per minute left, in 3 minutes, that's around 900 people that left. And then the same thing from three, this is another 2 minutes times, okay, I'm almost out of time. That's good. Good to know. So then in 2 minutes from 3 to 5, there's 300 people leaving per minute. So 300 times two, that's 600. And then over here, for another 10 minutes, we could say the people leaving at a rate of 100 per minute. So it's 100 times this 10, so that's going to be another 1,000. So in total, it's going to be 900 plus 600 plus 1,000, which is roughly 2,500 people who left the stadium. So that is going to be B. All right, we have this one more right here. This one's probably just going to be a guess for me. The AP Calc exam, that's completely fine, I guess. Um, oh, I'm pretty sure that it's C. The reason why I think it's C is because there's the theorem, the mean value theorem, and this is a condition. It's like if f is defined for all values between like a and b, it's like continuous, and then you have one value like a is equal to 14 and then b is equal to 2, then a value in between 2 and 14 must be possible, right? And if you think of it something like this, right, if it's continuous, if you have like 2 and 14, you're traversing through every possible value between 2 and 14 if it's continuous. If it's not continuous, you can go somewhere like this, or you could like jump around all over the place, right? And then you're not necessarily meeting that. But if it is continuous, then you're meeting every single point from 2 to 14, which includes f of c of 8 right here. So that's why I'm going to say it's C. A, I don't really know the solution or like why that is not incorrect. Um, I I feel like okay, I think this is just a very nitpicky question right here. But I think you could have something that goes through 8. And yeah, you can have a function like this that goes through 8, but then the integral does not exist. So yeah, if the integral does not exist, then I don't think so it's even continuous. So yeah, yeah, you could make up some random graph, I guess, that where it's not continuous or like the integral does not exist, and you can still have it pass through 8. So f of x does not necessarily need to exist in order for f of c of 8 to occur. Yeah, but if f of c is equal to 8, if this is continuous, it's always going to be the case. There's going to be some value that equals 8. So we just ended right on time. That is pretty epic. See how we did. It's going to take some 9 out of 10. Okay, so I did mess up on one. Oh, was it 9? F prime. Hmm. Okay, so I've just been blurting out a bunch of stuff then. Why is it F prime? Hmm. Why is it F prime? So ensures I don't necessarily know why it's F prime. Because okay, let's just think this is F of 2 is equal to 8. Which is the following? Okay, let's search up mean value theorem. Okay, because I know what. Oh, I see. So it's part of the theorem, I guess. So, hmm. Okay, so if you say A to B is continuous, but if the open interval A to B, if that's differentiable, then yeah, anything that's differentiable from one interval to another, if that's differentiable, it's already continuous. So right here, I guess right here, when you say C, right, it's continuous, but it's not differentiable. Here, when you have f prime is defined, that means f is differentiable, which means that it's also continuous as well. So then, yeah, I think, yeah, then B would be the answer there. But I'll still need to do a little bit of research as to we need the, why we need the different, why do we need the derivative to be existent? I don't know necessarily why, but yeah, I guess that's it. Thanks for watching, and hopefully you'll stick around for practice quiz number 4. All right, thank you.